A very warm welcome to our session here. We're excited to have you joining us in SkillsFuture Month at SIT. I am Joy, an undergraduate student from SIT, and I will be your student host for this session. The title of this session is Data Visualization for Intuitive, Informative, and Interactive Data Analytics. We are honored to have our speaker from Singapore Institute of Technology, Assistant Professor Zhang Wei, who will be speaking to us. Dr. Zhang Wei is currently an assistant professor with the Information and Communications Technology Cluster, Singapore Institute of Technology. His research interests lie in utilizing artificial intelligence for smart cities, especially smart grid and smart buildings, towards improved user experience and enhanced sustainability. Without further ado, let us welcome our speaker, Assistant Professor Zhang Wei.
Hi, hello everyone. So thank you for the introduction. And so I share my screen. Yeah, I am Zhang Wei, a faculty from SIT, and today our topic will be data visualization for intuitive, informative, and interactive data analytics. So roughly this workshop will be 35 minutes, where 15 minutes is in the slides, then 15 minutes demo, then finally 5 minutes conclusion and the discussion. Okay. So first, we know that currently data is everywhere, and we know that data is increasing explosively. And most of us has social network, and currently the active population of the social network is 4.2 billion. So which means that most of the people on the earth has at least one social network account. And regarding the average daily usage of the social media and the social network, like watching YouTube and posting in Facebook and Twitter, then we spend 2.4 hours on average every day. So nowadays, you know that for younger generations, they like TikTok a lot. Maybe not for like senior generations, but for younger generations, they do like this a lot. Then every day, the daily views only in TikTok all over the world is 1 billion. So it's a fantastic number. Then we can imagine that with this scale of the social network and how much data we are going to have, it will be a lot. So social network is relatively human-centric, and we also have relatively less human-centric social usage, like for IoT. And IoT is important for smart cities, like smart buildings, smart energy, smart transportation, smart healthcare, and so on, right? A lot of the different smart things. Then the basic idea of those smart applications is that we deploy sensors to monitor the real-time and operational dynamics of the system. Then also we can support the real-time communication of the system. So it's an IoT. Then you can imagine that how much data we are going to generate, because there are just simply too many sensors to collecting the data for us in real time. And it's estimated that by 2025, just 3 or 4 years later, and roughly the IoT data will be about 80 databyte. So 1 databyte is equals to 10 to the power of 12 gigabyte. So 12 zeros of gigabyte. You can imagine that how much data we are going to have with the IoT facilities. So now we know that we have a lot of the data, but our problem is that what can we do with the data? Is the data valuable for us? Yes, it is. So if we think about the usage in a time scale, so in the left time scale, we say that we can understand what happened in the past years or past months. For example, we are using manufacturing equipment or facilities. We can monitor the degradation of our devices in the past months or past years, right? So we can understand based on the data. And suppose we are looking at the current time slot, and we can also monitor what's happening now. For example, how many people are there in the MRT station, and with those information, we can accordingly optimize the traffic flow or those schedulings of the MRT, right? And we can also predict the future and what will happen. In the future, maybe our application can be the market. Okay, we would like to investigate what will happen in the market in the next month, in next year. We can do those predictions. So data actually can be really helpful. Okay. Then our idea is that we know that data is helpful, but how can we really utilize the data and how can we deal with the data? So in the beginning, actually, it's not a perfect situation. In the beginning, actually, the quality of the data is not good enough. And for example, suppose we have some contractors to deploy the IoT solutions for us. Then after we get the data, sometimes we will find, for example, the temperature data. Then you will notice for some hours or some days, there is no value in the temperature data. So basically, there are missing values. And also sometimes there are also outliers. For example, you may say that the indoor temperature is 100 or 1,000. So basically, you can say that the sensor is not working correctly. It's more functioning. Then for all those missing values and noise data and so on, and we can do this in data cleansing. So this is quite a tedious stage of dealing with data. And after we do the data cleansing, we also have to consider the data integration part. And for example, we have sensors to deploy it in different geolocations. And how can we do the synchronization? To synchronize the data together, then we can merge them, integrate them into the same storage. Okay, so this is data integration part. Normally, people would say that define the data pre-processing to be the combination of data cleansing and the data integration. Okay, people call this pre-processing. And after this stage, and we can roughly assume that the quality of the data is there, and we can trust our data. Then if the quality of the data is there compared to the original data or the raw data we have, then we can say that we can save the data into a database. Then for this database, we can use it for data storage, for data management, and so on. So now we are in a new stage. We have the data in the database. And our question is that, are we really ready for data mining with the data in the database? Are we ready? Actually, the answer is no, right? We are not really ready. And I just gave the figure that you can see in the second figure in this slide, and it's just a screenshot of the data from some IoT contractors, right? You can see that basically there is just too much information, and there are many numbers, values, and text, and it's really hard for us to instantly get an idea about what data do we have, right? It's so difficult. And specifically, we know that raw data, the quality and readability is far from user-friendly. It's not intuitive enough. And it's really hard for us, the customer of the data, to understand the meaning of the data. So it's true that for many companies and even for many institutes, they spend a lot to collect the data, but eventually they find that the data is underutilized because they don't know how to utilize the data properly when human is the end customer. So now we have a new question. And yes, we have some data. The quality is good, but this quality is from the perspective of computer, not from us. Okay, then our question is that how can we extract the value from those data in the computer, right? Then there are quite some solutions. For example, you can hire some scientist, and you can outsource, maybe get some consultation, and outsource some jobs to the other IT or CS companies. But one of the solutions we would like to introduce today is data visualization. So data visualization is not really a high-tech solution, and also from the perspective of cost, it's not too much. Okay, we will introduce more details later. So first, what's the definition of data visualization? So for simplicity, data visualization is very simple. It's just graphical representation of the data. So here you can see the second figure, it's just too much information, but it's really data. And we can't say that the quality of the data is not there. The quality is there, but it's for computer, not for us. And the representation, the carrier of the information of this data is numbers and text, right? So, but for human, and we are good at what? We would like to say that the carriers of the information is graph, figures, instead of values and numbers or text, right? So we would like to represent our data graphically. And also it's true that humans love visuals. And I believe for many of you, then suppose you are reading a book, many of us, then we feel sleepy, right? When we are listening to lectures, we feel sleepy. But when we are watching YouTube or like watching some funny videos, then we don't want to sleep, even it's 12 a.m. or 1 a.m. It's human nature. And also, you know that even for Iron Man, we never see a movie that he looks at the Excel or text file. So all the elements are just some visuals in Iron suit, right? And we know that we have the capability that suppose we would like to identify red and blue, we can do this instantly. And if we would like to identify the difference between square and circle, we can do this instantly. Large and small, also we can do this instantly. So it's really fast for us to digest the information from a figure or graph. And from the figure and graph, we can see the trends, outliers, patterns, and so on. So basically, if we have graphs and figures, it's just like storytelling. And with those good stories, and we can just internalize the information in a fast speed. And also, I would like to mention that another advantage of the graphical representation is that it's insensitive to data volume. We mentioned that we will have a lot of data, but how can we manipulate this large scale of the data? How can we digest and intuitively understand? And suppose we have data visualization, for example, a pie chart, and you just would like to identify some fractions of the pie in your pie, right? If you have 10 points, 1,000 points, 1,000,000 points, will there be a huge difference? No, there will not, right? Because you care about the percentage of the in this pie chart, right? So you don't care it's 1,000 points or 1,000,000 data points. You don't care. So basically, it's an advantage of data visualization. It's insensitive to data volume, and it's big data friendly. And we know that in the future we will have big data. There are some popular graph and figure types, for example, bar chart, line chart, and pie chart, and so on. And now our question is that we know data visualization is one of the technology for us to understand our data. But now our question is that how can we generate those graphs and figures? So we propose to code by ourselves. Okay, maybe in the beginning, some of our audience may say that, okay, we have to code. Will that be too difficult? And actually not really. There are some advantages of coding-based data visualization. First, suppose you are using some libraries for visualization, especially in Python. And nowadays, most of those libraries are free and open source. And you don't have to pay anything for those libraries. You can use that for free. Okay, so you can manage your budget and investment. And also you have full control. And it's really easy to customize. And what do I mean by full control? Imagine that you are generating a plot in Excel, for example. Suppose I have the specific requirement to say that for the 10 graphs or 10 figures you are going to generate, I require the height will be 2 inch, the width will be like 3 inch, for example. And how can you specify accurately about the height and width in Excel? It's not so straightforward, right? But if you are doing this in the coding level, it can be quite straightforward. And here we propose that you do this through Python. And Python nowadays should be the easiest language, programming language. And even for people with no coding experience, and many of them can pick up the skills like within a few days or 1 week or 2 weeks. Then they can start to plot some basic graphs and figures. We introduced some libraries available that are free and open source in Python. One is Matplotlib, and this one is derived from MATLAB. I know that for many of us, we have the engineering background. And if you have engineering background, I believe that many of you are familiar with MATLAB, right? So you can see first the three letters MAT, right? This one is actually derived from MATLAB. The basic idea is that this library is very similar to the visualization functionalities in MATLAB. And they have similar parameters, and even the figures looks very similar. Okay, so for those who has experience in MATLAB, then this one can be a good option. And we also have Pandas. Pandas is more for data manipulation and management, but it also supports the visualization. But its visualization capability is built on Matplotlib. Okay, and we also have Seamborn. This one also similar to Matplotlib, but it can give us fancier figures and graphs, and also can give us some statistical information, like how can we do a regression line and how can we say the distribution, all those information. And for people from the business and economics background, many of you are familiar with R, the statistical software. And this ggplot library is based on R language. So if you are familiar with R language, then this ggplot can be a good option for you to use as the visualization library in Python. We also have Plotly. Then this one can support us to do interactive plots. Right. So in the following part, we will do a short demo to say that how can we really write some code in a Python environment to generate some figures and graphs. So those are some very simple, very basic code I prepared in those days. And for example, here we would like to visualize some data that we have about the energy consumption. So for energy consumption, what are the files? It looks like this one. This is the data we can download from the website. And there are some energy data. If you double click, you will see it's too large, so we can only visualize part of it. We can see building ID, the ID of the building, the meter ID. So basically it tells us it's electricity or chilled water or steam, whatever. Then also have time and the meter reading. So you can see it's a 0. The meter reading is 0 for this part. But then in this tuple, we say the meter reading is 53 kWh in this hour. So we have those information. And we also have the building information. Like in the building side, we have ID and the primary usage. So basically it tells us the type of the building for education or for entertainment or for office, different functionalities. And also the floor area of the building in SQFD, like square feet, like 7,000, and this one is larger. Then also the year of built and the floor count. We have those information. Okay. Then our first job is to load this data into our Python environment. Okay, we can load them into the Python environment. Then in our first visualization idea is that how can we generate a plot? Because it's an energy data, right? So our idea is to visualize what's the change of the energy as a function of time, right? Then we can say the pattern of the energy profile of a certain building. And for example, here we consider the first building number 0, and we load our library in Python, which is matplotlib. And first we create a box for generating a plot. Then this box we specify the size should be 5 inch in width, then 2 inch in height. Then it's a box. Then we say that we call the plot this function. Then we generate a plot inside this box. Then specifically in the x direction, it will be time. Y direction, it will be meter reading, which is the energy. Then let's see what will be the figure we can generate. So this one will be the figure we can generate, right? So then we can say it's relatively intuitive. And we know that the energy consumption before 2016 May is very limited. And after the 2016 May, then we have significant energy consumption of this building. Okay, so maybe our information, the information is that the building is not really in operation before 2016 May, then it's in operation after that, right? But if we would like to say some limitations of this figure, there are some drawbacks of this figure, and I just name a few of them. The information is not comprehensive. So like for the X direction, so we should get some label, like the meaning is time, right? Maybe in the Y direction, we should get some label. Maybe in the meaning is energy. Specifically, the unit is in kWh. Maybe we can also give a title of this figure and also give a legend. And also maybe we say that energy profile intuitively, suppose we consume energy, it's not good for sustainability. It's not for green Singapore or whatever. So maybe the color should not be blue, should be red. It's subjective, right? But we have those requirements. And also we might say that it's too close for the X ticks, right? So like for 2016 November and 2017 January, it's too close. We can't differentiate. So then we have some fine tune of the graph. So we make the graph longer, and we also specify the color and specify the X label, Y label, and title, and so on. Then we can get this graph. Okay. Then if you compare, so the second one looks much better than the first one, right? We can even have the grid. Like, what's the purpose of the grid? Suppose you are looking at the left part, it's fine because it's close to the the labels in the Y part, right? So you can identify the value is 100 and 200 easily. But in the right part, you can see it's quite far away from the 100, 200, 300, those ticks. So suppose we have the grid, then it's much easier for us to identify the values of the energy consumption, right? So we can fine-tune our visualization and plots to make it more intuitive. And also sometimes we say that we are not satisfied with only one building, and we would like to do some comparison to say what's the difference between building number 0, building number 1, building number 2, building number 3. Can we do that? Yes, we can. So the only difference is that in the beginning, we have the box of the figure. Then we can just divide this box by like 2 by 2 to 4 small boxes. Then we can generate one plot in each small box, right? So we can put 4 plots together in the same box, same big box. Then I will show what you will say if you do in this way. Yeah, this is what you will have after you divide the space into 4 small boxes, and for each small box, you generate the plot for one building. Specifically for the top left, you will have building number 0. Top right, you have this one, the building number 1. And also the bottom layer, you have building number 2 and building number 3. So suppose those are the information we have. And suppose our idea is to do some energy optimization or scheduling or investigation. And if I ask which one we should pay more attention to, shall we pay more attention to like building number 2, or shall we pay more attention to building number 3? Actually, with those data visualization, it can be quite intuitive, right? And we can visualize the energy consumption of building number 3 is much higher than building number 2. So suppose our bandwidth is limited, and we should allocate our bandwidth into those large consumers, and we investigate in more details, like building 3, what happened that you have this high energy consumption? Then how can we really optimize it to enable the power grid stability or cost effectiveness or those considerations, right? So all those insights can be extracted intuitively from our figures, right? And sometimes we also would like to visualize the distribution of the energy readings, so we can use histogram. So you can see the only difference in this part, we are using the plot function, right, for the time series. And if we would like to use the histogram, we can just use HIST. So simple like this. And we say that we would like to check the distribution of meter readings. And this is visualization we have. Okay, this part of my point is that visualization is we need some interactions with visualization. Sometimes it's impossible that in the beginning we have a perfect visualization. For example, this visualization is not really informative for us because most of the engine readings is concentrated in the small readings, and most of the space in this graph is blank. Okay, it's not informative enough. Then if we do some investigation of what happened, then we can say that basically in our data set, and suppose we consider the meter readings of 0, we have almost 10% of the meter readings is exactly 0. And we only have 8% of the meter readings with larger meter readings, larger than 1,000 kWh meter readings. And suppose the criteria is 10,000 kWh. We only have 4,000 of the buildings or the readings. So then we say that we consider a large range, like in this figure, is the right part is 10 to the power of 7. It's unrealistic, right, for our data set. So we try to limit the range a little bit. Then we fine-tune the figure a little bit. For example, we only consider the meter reading between 0 and 1,000 kWh, a moderate range. Then we can say that the figure, the information is more informative, right? We know that, yes, most of the readings are quite small. Then we can also identify the pattern. It's decreasing. And also this decreasing is not linear. It's decreasing fast, right? Then if our objective is to look into the large consumers, and it might be sufficient for us to only consider the consumers between 750 and 1,000. And you will know that there are not too many consumers in this range. So it enables us to do a more efficient investigation and study, right? So it's a story that we can tell based on this histogram. And we can also generate some box plot. The box plot basically gives us some distribution. Like this one is the meter reading in different months. Suppose we consider the leftmost box. It's corresponding to the January data. And for the black part, actually it's some dots, but it's too many dots, so you can say it's the black area, but it's basically outliers. And suppose you check the this part, the 400 kWh, it represents the maximum value of our meter readings in January. And 180, it is roughly 70% of the meter readings in this level. And the orange line is the 50%, the median meter reading in January. And also we have like 25% and the minimum meter reading. Then basically for the end readings in January, we can represent as a box, can tell us the statistical information, 25%, 50%, 75%, all those information in this box plot. And we can also look into the big picture. Then in this big picture, we can say that roughly like in June, July, August, and September, we have a higher energy consumption. Then we go back to look at our data. We know that we specify the meter type is warm. And the meaning of warm basically tells us we are talking about chilled water. Why that we need chilled water? We need that to cool for air conditioning, for cooling, right? So when do we need cooling? We need cooling in the summer period. So then we can confirm based on this visualization and graph, we can confirm what happened in the energy consumption. Suppose we are using the chilled water. And maybe we have some more requirements to say that we don't want these outliers and we want some colors. Yes, you can do that. And I just show a sample figure. Then you can remove the outliers. Then you can get some colors in the box plot. So it depends. Some people like the first one. Some people like the second one. It depends. And we may also say that are we able to integrate the entry data and the building data and do some other plot? Yes, we can. Then we just demonstrate a few examples. So this part we demonstrate the scatter plot. Scatter plot, the basic idea is that you have X, you have Y, and every data point in your data file, every data sample in your data file will be just one point in this 2D plane, right? So after you generate this plot, you will see, like in the X direction, it will be the floor area in 1,000 square feet, and Y direction, it will be energy reading. And you will see the distribution of all your data samples in your data file. Then immediately you will find the pattern. Basically, suppose you have a large floor area, likely you will have large energy reading, right? So you can see the increasing pattern. And also most of the reading you can see is concentrated in the small readings. So you have all those information. And suppose you would like to make this graph more informative, actually you can, right? For example, we just demonstrate one usage, and you might still remember that our meter types, there are electricity, chilled water, steam, and hot water, okay? For example, suppose we would like to differentiate the chilled water and other meter types. We can say that as long as it's chilled water, you change the color to red, and otherwise you make the color as blue. And also here you may notice that different points can overlap, and we would like to avoid this overlap. So we can say introduce some transparency to the data, to the points, right? For example, this alpha equals to 0.5. It means that 50% of transparency. And this will be the data we have. And we say that most of the data will be concentrated in the bottom part, which means low energy reading. And we can also check the red point. Then for the red points, we know that they are corresponding to the chilled water. And we know that in our data set, there are only likely 2 buildings with 2 specific floor areas has the energy reading, meter readings for chilled water. Okay, it's only for like roughly 2 columns. Then you can see the distribution of the red points, right? So it can be even more informative. And maybe sometimes we also would like to use some other libraries, like to integrate some more information into the plot. Actually, we can. So I just introduced one example using the symbol library. And this is what we are going to have. It's still scatter plot, but you can also see distribution of the floor area and distribution of the meter reading. Then you know that relatively it's normal distribution of the floor area. And for the distribution of energy reading, it's not uniform. It's like what we introduced in our first figure. Okay, those are just very basic demonstration of how we generate graphs using our data. And it enables us to understand our data more efficiently, right? So then is our last slide. Is about some discussions about visualization. And we would like to say that visualization is not really purely a technical thing. So when we are generating visualization like graphs and figures, we also have to be careful about the subjective requirements of our customers. And it has to be user-friendly. In the end, those graphs and figures are not for computers, it's for us. So we have to consider the user-friendly part. And for example, maybe for some people, they like black and white. And for some other people, they like colorful graph and figures. So we have to know the difference between the different customers. And also visualization is not limited to the beginning stage like raw data as we introduced. And you have raw data in the beginning, and in the middle, you also have the intermediate data. And after the research and project, you have some final results. So actually, the visualization applies to different stages of the data processing. Even in the results, you can also visualize it, right? Like say in the second figure. So that the basic idea of this second figure is the results of our research. To say that we are using our mobile phone, and we would like to save some energy for transmitting for transmitting some data. So our idea is that you can do some compression But if you do compression, you will consume computation power in your mobile phone. And if you don't, you will spend more in transmission power in your mobile phone. So there is a trade-off, and there will be an optimal point. So roughly that, like, you compress maybe 40% of your data, then you can minimize the energy consumption of the summation of transmission and the computation to minimize the energy consumption of your mobile phone. So you can say that basically we can also use a graph and figures to visualize our research results. And another interesting part is explainable artificial intelligence. And you know that nowadays people are talking about data and AI all the time, right? So we talk to different people, they are working on AI. But when we look into more details, to say that we find the fact that many companies and many institutes, they don't really deploy the AI solutions in their products. Why? It's very simple, because one of the key reasons is that they don't trust the AI models. So suppose they don't trust, then they don't have the confidence to use the AI models. So then our idea is that we should introduce explainability and interpretability into the AI models. They are black box, so we demystify those black box. And how can we do that? So one important skill is visualization. And we visualize the relationship between input and output. We visualize how you make the decision. So for example, in the right part, we have the demo figure. So for example, I tell you, suppose I have an AI model, and I tell you that in the next hour, I predict 95% likely you will have large energy consumption. Then you would like to know why. Why that you say 95% likely I will have large energy consumption. Then I will tell you the reason. The reason is that because your building is large, you have a large floor area, and also the outdoor temperature is super high. And also it's after 8 a.m. So it's in the peak hours, right? It's not in the non-peak hours. So based on all those conditions, we predict that you will 95% likely you will have large energy consumption. Then with all those explanations and interpretations, the users will trust our models and are more willing to adopt the AI solutions in practice. So in general, we argue that data visualization is really powerful, and we really should allocate some effort and bandwidth to fully release and explore the power of data visualization. So this is the end of my presentation, and we welcome any questions if you have. And here's the contact information. You can either post your questions in the chat box, or you can also email me in the future. Yeah, that's all. Yeah, we look forward to your questions. Thank you. Hi, I cannot see the questions. Where is the questions? I opened the discussion forum, but there is no questions in the discussion forum. Let me get a live. Oh, I see some questions here. Yeah, let me see. What types of the plot would you recommend to analyze and discover the relationship between variables and multivariables data set? Okay, it depends. Normally, we will start from the basic information. Suppose there are some close relationship between the two variables, then normally you will have a 2D plots, right? 2D like either plot and and scatter based plot. But if it's 1D, suppose your only consideration is sales, then you will get the distribution in histogram. Okay, so it depends. Or if you would like to get some summarized information, then you can do some statistics to say how much percentage in this category and how much percentage in that category. Then you can do some pie chart. Yeah. But as I mentioned, data visualization sometimes is an interactive process. So we just try, and until we find a satisfied solution and satisfy the layout of the graphs and figures. Would the Jupyter file be shared with the audience? Yeah, if you would like to have a copy of the code file, you can give me an email. Then I can share the Jupyter file with you. Yeah. One more technical question: how do we run this code on web? It's also very simple. You Google Anaconda, so it's the if you install Anaconda, then by default you will have most of the Python libraries inside. Then it will also give you the functionality that you can code using your web browser. So it's a very quite straightforward. Yeah, most of the people, like some of my students previously don't have a coding experience. They can learn this Jupyter just then they can start to code a little bit. What's the recommended data visualization tools for students without engineering background? Yeah, I mean, suppose you would like to code by yourself, then you can just start from Matplotlib. That one is the most popular. Then, if it's most popular, actually indirectly there are some observations. First, why that is popular? Because it's simple, right? Only the things are simple enough, then it can be popular. And also, if it's popular, then in the future, suppose you have any questions, you can just Google it. Then because there are many people are using this one, then it's also easy for you to find an answer. Suppose you have some problems and questions, and because very likely other people also have similar questions. Also, there are many many discussion web page and start guide, and you can follow the simple examples to practice. Yeah, I would say it's not so difficult to pick up at least the basic skills for visualization part. Oh, my email address. Let me share my. How can I type my email address? Let me share my screen. Give me a while. Yeah, if you can say, here's the email address, or if you want to search, you can just search Zhang Wei SIT. I believe you will say the results in Google. Let me try. Yeah, then you can get my email address. Yeah, I stop sharing my screen. Yeah, just for this variable, the relationship between two variables, then normally it's you can consider 2D, 3D plots. Yeah, you can just try a little bit. But suppose you have too many variables, then another one is you can also create a matrix. Then the matrix, the basic idea is that suppose you have 3 features, then the matrix will be 3 by 3, right? Then maybe for the first row, column 3, it represents the relationship between the first feature and the third feature. Okay, so you can visualize all the relationship between any pair of two features all together in the same graph. And also in the future, suppose you would like to get some more in-depth insights from your data, like multivariable, then you can also use some machine learning basic models like linear regression, for example, the very basic one. It tells you the relationship of your output and your input, and there is a coefficient to each input. Of course, you can make it more complex and more advanced using some more advanced models. Yeah, but there are some solutions for you to have in-depth understanding of the multivariable cases. Power BI, Tabular, Python, R. Mostly I only use Python. Yeah, because for me Python is enough. So I don't use R. Then for Tabular, the reason is that I have to pay. So if Python can satisfy my requirements, then I try to avoid some commercial softwares, so I don't have to pay a lot about the license fee. But suppose you are running a company, then yes, you can consider like Microsoft Power BI or like Tabular, because they are more commercialized and can give you like better support, business part of the support. Sure, can wrap up. Yeah.
All right. Thank you, Assistant Professor Zhang Wei, for the great sharing and insights. We have come to the end of the session. Thank you all for attending, and we would like to hear some of your feedbacks. You'll be provided with a survey right after this session, and do give us your valuable feedback. Thank you once again for joining us, and continue to enjoy the rest of the sessions today.